wanted to talk about your basic applications of an angle, understanding how it fits together, the terminology we used so far with angles. We're not going to talk about any of the trig stuff yet today, that we focus on tomorrow. First four, we'll get into each one of those and how they kind of fit together. But the idea is to again reinforce what an angle is, how to draw one, how it fits together with the other subject we talked about. So, as a reminder, geometry. In geometry, we learn a definition that is based upon how to fit into a structure. How to put an angle into a square, into a rhombus, into a triangle. Everything we learn about angles is defined in those principles. We learn in geometry like acute, obtuse, right, some of which is still useful, but most of which is purely based upon geometry and the triangle methods we're using in geometry. In trig, we start transitioning into a more holistic view of understanding an angle by using the unit circle. Now, we can take any angle of any size and transpose it onto the unit circle itself. Meaning, if I want to draw a 3-degree angle, I can draw that angle what we call standard position on the unit circle and talk about its properties. Again, from our quiz, a 591-degree angle. In geometry, this is an impossibility. You can't put one of these angles into a triangle, or a square, or a rectangle. You can't take the functions of these, even the bigger shapes, and add them together and get to a number like this. It doesn't work. There's no physical way to make this happen. In trig, these angles happen because it's based upon a different concept. Rather than just being the space in between two rays, which is the geometry definition, where we try to take a ray, the space in between. Now we look at an angle as the motion of an angle, the spin of an angle. 591 degrees is instead drawn using the unit circle. We take our standard axis grid. At 591, we start in standard position with this kind of 0, and we start going around counterclockwise, going up in degree. So the angles from geometry still work, for the first sets anyways. From here to there is 90 degrees. Continuing past that is 180 degrees. But once we get to 180, we start to leave some of the geometry terminology behind. This is primarily because these angles don't work in triangles or rectangles. Even if you have a concave shape, some of these angles stop working. When you get to things like 270, and then again 360, and some concave shapes, you can get an angle that's as big as 359 degrees, or even just a little bit closer to 360. Once we hit 360, we leave geometry entirely. You can't have a 361-degree angle and do geometry with it. It doesn't work. It doesn't make sense. You can't draw that into a triangle or any other standard shape of geometry. So we just go to trig. Trig says that 361 degrees is just 1 degree past 0 after a full rotation. So again, 361 degrees.
Teachers, I need Bradley Skaggs and Kobe Rowland to the office. Bradley Skaggs and Kobe Rowland.
As weird as it seems, 361 degrees is one revolution, 360 degrees, plus another degree. It seems like it overcomplicates things, but it's necessary to understand how these angles can exist. Otherwise, it doesn't make sense. How do you draw an angle that's 361 degrees when you know a full circle is 360? You have to be able to go past it. So, you get 591. The tradition just continues. As this angle keeps going around this circle, it just keeps getting bigger and bigger and bigger. So as I keep going, this 360, instead of being a 90 up here, could also be 450. We add 360 to that and get to 540. Let's talk about bigger and bigger angles just by referencing where they are located in relation to that circle. Find that 591. Add 90 that one, so this would be 630. Too far. At 591 degrees, will be right there. So it is from the base angle, 1 revolution out to 591 degrees. Again, this is meant to cover the gaps that end up being possible in geometry. Because these gaps are huge, right? In geometry, in traditional angle formulas, 0 to 180 is the most common ones. So getting past 180 only happens in very smooth shapes called concave shapes. And then even past that, you end up at a very stiff bend. You can't get past 360. It's a barrier. In trig, we go wherever the heck we want. We have to think about it in a very specific way, in a way that guarantees the same solution every single time. This way. Now, next thing we talked about is the first one referenced in our quiz. Coterminals. Because the idea that this angle, 591, because of how it is built, how it is constructed, by taking this angle and spinning around an axis, it can be found to be similar to other angles in the same position. Coterminal. There's an easy way to find out the coterminals, adding and subtracting 360, which makes sense when we construct them this way. Because adding 360 just spins it one more time. You'll always end up in the same spot. Take 0 degrees and spin it, it spins all the way around, ends up at 360, same spot. Add 360 again, you end up at 720, same spot. You keep adding 360, you end up in the same spot, just different numbers of spins. As we go past this, we can talk about individual angles by using their coterminals. Again, adding or subtracting 360 to find a new angular value. We specifically talked about how we wanted to put this into the unit circles list, taking these angles that are too big for the unit circle and restricting them down into ones that are near the unit circle. In this case, at 591, we subtract 360. We end up with a solution of 231 degrees. This is the preferred one to talk about because this can be talked about with geometry. And because coterminals will have properties of geometry that work. Again, the components of these angles are based upon their relative position, size, and location of the unit circle. So 591 is talked about the same way we talked about 231 because of the same angle, just after different number of spots. We can add 716 again, find another coterminal, and another, and another. There are infinitely many coterminals in both directions. Coterminals that are less than 0, negative coterminals. Coterminals that are bigger than 0, positive coterminals. So, 231 is a positive coterminal of 591. But it's the better one to talk about because it's on the unit circle, therefore will fit specific geometry properties. Go into the negatives, if it happens, subtract 360. That's giving us our first solution to this problem. Subtract 360 again, we end up with 129 degrees negative. There are more, of course. Just keep subtracting 360. You'll keep getting more coterminals. Make sure that on your test, you list one of each. One positive, one negative. Yes, ma'am? You didn't read that. Nope. So, acceptable answers here. The positive. I could have had the 231. Or I could have had, let's see, add 360, mental math, 951.
651.
651?
Plus I did 591 plus 360.
Add 360 to that, please. Should be 951. Either one of those is good. I can keep going if I need to. Like I go up to like 1311 and get another one. All these count for the positive. Because they were all positive angles that are the same as the angle that's our question, the 590 angle. Did you hear what was wrong with the book?
I don't know what 6, but I have a 50.
Ah. Alright. The negative. First negative that's accepted, negative 192, 129. More than accepted would be like, 489? And 849? Any of those would be acceptable answers as a negative. So you can take one to the top row and one to the bottom row, and you have a correct solution. Because those are one positive and one negative coterminal. Coterminal literally means same location. There are infinitely many correct answers. There are also infinitely many wrong answers. You have to follow the process to get to your solutions. Now, let's go. Second part. Reference angle. We talked about reference angle last week. Reference angle is defined as, so in very basic terms, the coterminal takes any angle and puts it on the unit circle. It's somewhere in the circle. This 591 is actually over here at 231. It's another spin past it, but it's over here. I have a good reference for it. I can easily see where 231 is. It's much harder to conceptualize where 591 is. So if I have to talk about 591, it's easier to talk about 231 because I have the picture for it already. Again, if I talk about angles in the millions, conceptualizing that means you can't do it. It can't be done. The smartest people in the world can't do that very easily. I'm not saying you're one of those people. I'm saying even if you're striving to be one of those people, it's still tough. So instead we look at it and say, it's much easier instead of looking at 1 billion some odd degrees to look at 37 degrees. As long as they're coterminal works. Reference takes that same idea to another extreme and puts it into the basic set of geometry between 0 and 90. The common ones for triangle math. So the reference angle takes all the angles that are on this unit circle over here and condenses them down into just the first quadrant. And again, it retains specific properties, just like 231 and 591 contain certain properties. The reference angles will retain certain properties as well. Now, define the reference angle. In this case, 51 is right. That is the only acceptable solution. So any of the blue angles, any of the red angles is acceptable. 51 is the only acceptable reference angle. It's the only angle that is in the first quadrant. Now, we talked about a lot of formulas that you can use. There's formulas to know which quadrant it's in, which is helpful as long as you know the quadrant. But that's why we use coterminals. Coterminals can put it in the right quadrant, and with the right quadrant, we use the right formula to find our solutions. As I said in class, there are many alternatives to this. So you guys already found some, and we're testing them out. Some of them work great, some work half the time, the other half the time they don't work. The formulas I gave you work every time, but it's 4 formulas memorized. We're taking the original idea. The idea of the reference angle is the distance from the x-axis. If I go here to 231. 231 is down here in quadrant 3, so I could use the quadrant 3 formulas. Or I could think about it and go, how far is it from this axis? It's 51 degrees. Very simple calculation to do so. The idea is it takes this number and applies it into something smaller that's easier to work with, more malleable, simpler. 51 is easier than 231, and it'll have similar properties. 231 is easier than 591, and it'll have the same properties. So again, it takes the complex and makes it simpler. The only difference between these and the radian ones are harder to work with for some people because fraction math. I told you guys in class, you are welcome to convert them to degrees, or you're welcome to take these problems and find them in terms of radians. I don't care which one you take. Here's the go-to rule of thumb. Thumb rule. Ready? When you start in degrees, you're going to give me an answer in degrees, unless I say otherwise. When the problem starts in radians, your answer needs to be in radians. Do I care how you got it? You want to use a certain formula? Do it. But if I start in radians, give me an answer in radians. If I start in radians, give me an answer in degrees, unless I specifically say otherwise. Alright. For today, we got 10 problems. We have half an hour. We will finish this early. Here's what I'd like you to do. We're going to make the coterminals, make the reference angles of these 10. We'll do 5 each, 5 radian, 5 degrees. Some will be in the unit circle already, some will be outside the unit circle already, so you have to use the coterminals to figure out the other pieces for them. Your goal today, I want you and your neighbor to have different answers for the coterminals. You should have the same answer, the reference angle. I want you and your neighbor. Whoever finds it first gets the easier one. Okay? Take this in the gym and look at it and see how these pieces are going to fit together. Here's your pieces. 10 problems. Again, for each of these 10. One positive, one negative. Don't care. Negative. Don't care. Very worse. Give me one of each. Everything needs to be correct. Let's do this. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's do it. Positive, negative, and the reference. A positive coterminal, a negative coterminal, and the reference. If there's anything you're confused about these ones, talk to a neighbor. Figure it out. These are things that we will be using as common terminology day one when we come back from break. I will assume you write it down. I suggest that be the truth. Alright? Here are your 5 degrees. Let's see here. Let's see. 763 degrees. 9,421 degrees. Negative 860 degrees. Why is there a period? I don't know. Just a comma. Because I can. Alright.
That's bad.
Negative 3,208 degrees. There's so many comments I can make here, Cole. You're killing me.
What do you mean?
Nothing.
Come on, let me hear them. Oh, you think you're funny, Dougie?
Always.
I got you.
I am funny.
I understand now.
Alright.
I'm always funny. We don't have to make them inside the unit circle, do we?
No, but they better be one positive and better be one negative.
Okay, cool. But we have to have reference.
36.
Reference angle as well. Okay? So, same instructions as on our quiz. One positive coterminal. One negative coterminal. And the reference angle.
What?
Alright. There are many shortcuts to making this simpler. Find them. Use them. You guys are smarter than you've sometimes shown. Okay? There are a lot of ways to make this math easier. The people who are willing to experiment and try them will often find that they are rewarded for their success. 6. Let's see. The pies. Agreed.
I'll use this. Why did you get Actually, I did it first. Oh, that's a big number.
Oh my goodness. I get the first one. I get the first one.
Alright. While we're doing this, I have some suggestions. Many of you guys are in the 400 dreams. You're going to be going to college in a year or two. If that's your choice. If you plan on taking math class in college, if form groups, find partners, make friends with people who are smart. They're boring. They need friends.
What are they called? Narcs?
Yes.
Narcs? That's what my sister calls them.
That's somebody who tells people that she's doing drugs.
Yeah, I did.
Reason being, in a lot of high school stuff, like teachers encourage you not to work together because they want you to not cheat. In college, you need to work together. It's you against the grade. All right. Find friends. Find people who are smarter than you. Find people who are sophomores, juniors, and seniors in college. You've already taken the classes. If you don't understand something, you got to figure it out. Find people that can help you. You can start that while you're in high school. Find people who already took a class and see what they remember. If they remember a lot, you remember less. There's a good chance if you look at, you'll find somebody that's smarter than you. They can help you out. They can learn a better way, an easier way. Us teachers are not always going to tell you everything. Oftentimes, there's an easier way that we're waiting to tell you later. Or maybe we forgot because we're getting old. If that's the case, somebody might have a better way that you're welcome to try out. Learn to collaborate. And if you are that smart person, charge them money. There'll be a lot of people asking you for help.
It's in the third quadrant. It's A minus 1 and right?
So, if you're looking for formulas, if you're looking for a process, I will be taking notes on that on the board up here. You're welcome to copy them into your notes if you're still confused.
No. Doug, I messed up.
You messed up, please.
I gotta start all over. Yes, I do actually. Just replay it. I don't even know how to do that. You gotta test it. I do.
I don't know what that word was.
It was.
I'm pretty sure it was a start to emo band song.
Yeah, it was. You're right.
Thanks,
Do you have
Annabella.
to show how many times you subtracted? You just have to get
No. Yeah, I hope not.
You do not have to show how many times you subtracted. I don't care. I just want to go journal.
I subtracted 1 time.
Good.
And I happened to subtract 720 million. Because why not? Large numbers.
I like it.
What?
I was gonna get the same money.
We should
No,
get the first
you
one.
do. So
Okay, that's fine.
then I can add 360.
What was that number? Okay, just do it.
It was like 60 million. Hold on. Wait. Maybe 2 million.
Where's that big one? What'd you say you remember there?
Notes. I have to work on some days, and some of the videos are hard to see, so I figure make sure notes are up there just in case you need them. Hopefully legible. Dear Lord, that's terrible.
Maybe I should do larger numbers.
No, I think you
Yes.
Maybe I should get to the billions.
Yes.
I think you should stop.
I mean, that's pretty easy.
I know, but it takes forever.
Nah, it's using the trick you're not using.
Oh well. He's
Yeah.
good
You're
at it.
doing it one at a time, aren't you?
No, I'm doing 720.
Yeah, I'm
I'm
doing
doing
like,
2 times.
I'm doing like
Then do 3 times.
I'll do
36
10
times.
1440 next
Do
time.
10 times.
There you go. I'll do 1440.
Do 3 times 600.
What? I'm doing like
10 times 360.
3600. 720 billion.
Oh yeah, we're supposed to work together. We are still at number 4. No,
Good thing. I'll make sure that's out of the way for you.
Let me get the other one.
Over 5.
That would be in the question.
Oh, that's not quite half.
After would be 2.5. That's a really common trick that some people just don't get. I love that trick.
I think what I just noticed that I did on my quiz, I didn't the positive or negative or referencing, but I just saw the clue part. I didn't read.
Ooh. I think I got a number in the billions. I got 5,759,999,863 for one of the coterminals on 5. I don't think I could get a bigger number, but then I'd actually have to do that.
Alright. Ready for a conceptual question? Which number?
What do you mean?
Which number? Try to phrase this exactly correctly. Is the only one whose absolute value is a coterminal of stuff.
Why do I do that?
Yeah, that's mine.
Okay.
Infinity.
Infinity is positive, so if I take the absolute value of it, it would still be infinity, so it would be coterminal, be the same thing.
Why would I get a decimal? I typed that in back there minus 2 side.
Yeah, I mean, one's
Okay, let's see if it'll do it. 84.
I didn't get that done. Yes, subtract 2 pi.
55 over 13. So,
Oh, I think I got a bigger number.
So 2 plus 13 is 6.
Wait, so we multiply the bottom number by 2?
So, if you want to add a fraction pi, it's 6. If you want to add a fraction.
Oh, I know what I got.
7.
No, I got a smaller number. So I got only 1 bill.
Oh.
It doesn't matter if it's a fraction. So,
I just have to go into the problem.
I would probably say, or like, this is just a count, right?
Yeah.
And pi is what would matter, right? It would be 84 minus 6. So it would be 8 pi over 13.
Yeah, you got it.
Only because I have to change the number. Okay. The radians are either adding or subtracting.
There we go.
Pi or 1 and 5. So like, what's your number right now? That actually is a.
Yeah.
I did use first part. 3 pi was actually pointing out something really neat here.
And it's a 6 of them.
Here's 0. Here's pi, right? The first quadrant is halfway in between, right? So you get over 5, right?
Okay.
Half of 5 would be 2.5. So this would be 2.5 is right here. So if it's less than 2.5, it has to be in the first quadrant. Bigger than 2.5, it has to be over here. So 2 pi over 5 must be in this quadrant. 3 pi over 5 must be in this quadrant. Okay?
Honey, come on.
That works.
You don't even want me buying food anymore.
Yep, that's what I said.
That's not the reason. What is the reason? Speaking of that, I'm gonna tell you asking me to do it.
What I said.
6 over 13 pi is not half. So
that would be perfect. Very nice, man. Very nice. Oh, wait. I almost forgot for the second day in a row.
I'm only on 7. You know, I definitely like having obscenely large numbers on my paper for no reason.
You know, Levi, I never would have thought about teaching how to estimate that way. I never would have thought about that. I do that automatically.
yeah, I do stuff like that, like with fractions.
That's good. I like this.
What? I mean, it's 7. Real. Number 7, 0. I'm just gonna stop talking out loud. I love you, dude. Shut up. No, shut up.
Oh, he's 13.
I said I love you, dude.
Ah. What do you think it was over?
3.
Yeah, that would do it.
Pi minus 6 pi over 7. I mean it right because that's 7.
So number pi would become 7 pi over 7. It's a single pi.
Yeah.
So you have 7 pi over 7 minus 6 pi over 7.
You can get a decimal. 7 is really weird.
So because number 13, most of the catch fields will not leave your answer in terms of pi.
1 over 7.
I wanted in 5. Now, there's a couple ways you can do that. You can try to guess your way to finding it, but typing in random numbers and putting 1 over 13 and see what happens.
I'll guess my way.
Or you can do it by hand instead of with the calculator.
And what'd you get on number 6? On what?
Referencing
7
over 6.
2 over 5 pi? No, why are you asking me?
You'd be surprised.
Well, I was just comparing. Yeah. Shut up. You didn't know.
I'm just gonna write the rest of these.
Yes, sir. We get butter. It's just so true. 26. What?
I wish you would have put larger numbers.
Hey, hey, number 7?
Yes. I want it in terms of 5.
Yeah, how do you do that?
Most Cassios don't like it.
See, I had some all like so like tomorrow, I'm not saying, oh yeah, I need to have number 7.
Hey, you got to figure out how to do it by hand.
Yeah, I'm not gonna tell you.
Oh,
Just do it over 13 and then subtract across the top.
very simple. You didn't think that one. No those fractions. So subtract 2 pi, you just subtract 26 pi over 13. Because remember, you can put the top and bottom by 13. And remember, remember, when you add or subtract fractions, you're doing the operation to just the tops. So add or subtract 26 pi.
I mean, I do more than 26. What, 52? I go up from there.
What is it?
104.
Okay, good. So what I did was, I want to add or subtract 2 pi, right? I'm assuming you want to subtract based on the segregation. Normally I would just subtract 2 pi and be done, right? But the calculator doesn't like that. Gives you decimal, right? So what I'm going to do, I'm going to modify the 2 pi into fractional terms. Ready? So to do that, I take the top and the bottom times 13. And what does this give us? Instead of 2 pi, I end up with
but that's just a guess.
26 pi over 13.
Hey.
Now what I can do now, this would be a good time to look up. What I can do now is actually subtract those two. But remember, when I subtract fractions, I just subtract the top and the top. The bottom will stay 13. The bottom's still 13. 84 pi is like 84x, right? The pi doesn't do anything. So I subtract the 84 minus the 26, and I end up with 58 pi over 18.
13 over 13
Sorry, yes, 13.
for a positive answer.
That is a positive answer.
So then you could add 2 pi to that.
So 13 over 13 would give you 1 pi.
Yeah, I mean,
You want to subtract 26 over 13.
okay.
This is how you do it by hand.
You could have like really anything you wanted. You could do 26 times like 200, and then have that answer pi times pi over
13 on top, 13 on bottom, maybe 52 pi over 13.
Of course you took that one.
Or then you could go up. You could go all the way to like 208 pi. I mean, that'd be no
No,
point.
it's
Unless you wanted a really big negative number.
Which could.
I'd rather just do an even bigger number. Maybe more worthwhile.
So Aiden, you were asking about doing it with 4 pi instead of 2 pi? So basically you're doing 2 pi twice. You're subtracting 2 pi. So again, I do that in 4 pi.
honestly which ones I want to change.
So you take this times 13. This would become, let's see, 4 times 13 would be 52. Pi over 13. Then we can subtract these two.
It's not fun.
84 over 13 minus 52 over 13. 84 minus 52 would become 32 pi over 13, which would be another positive coterminal. And that would be 4 pi instead of 2 pi. Remember, if you add or subtract 2 pi, we can do it multiple times.
I have a question.
Think about this way. You can subtract 2 pi, 4 pi, 6 pi, 8 pi, 10 pi. Those are all applicable.
You could subtract by like the 2 pi. You could subtract basically any even number. Well, yeah, any even like number times pi.
Yes, because that will in fact rotate it by an even amount.
So like 4 pi, 6 pi, and 8 pi.
Yes. 4 pi, 6 pi, 8 pi, they will all be accessible because they will all eventually be multiples of 2 pi.
486 million.
6 pi would be 3 rotations.
Yeah. So the ending answer is 7.
So I'm not
Would
getting
that be 6 pi over 13? That's what I got.
Yeah.
What's that got? The reference?
Yeah.
Yep. Don't forget your negative, it has to be a negative number.
Don't forget what?
Your negative coterminal, which would be a negative value.
I thought you were talking about referencing.
Reference angle should always be in that first quadrant.
Are we trying these answers?
Yep.
Yeah.
10 problems. How do you?
Hopefully not by the end of class. I can't do that.
Oh, you got 6 minutes.
We got 6 minutes. 3. Got 4 problems.
I finished before Scott.
Watch it though. That's not good. If for some reason you not get finished, I will accept having them turn at the beginning of class tomorrow. At the beginning of class tomorrow, the first two problems of the day will actually be in these two types of problems. No worries, you should come in and no worries. Come in, these papers back there up. We'll continue down the list.
Confusion.